Welcome to this edition of Design for IoT. My name is Prabhakar and I am a faculty member at the Indian Institute of Science. There are a few of my affiliations which I wanted to show you here in the screen. I primarily belong to the Indian Institute of Science and my department is the Department of Electronic Systems Engineering. You can see that I have highlighted it here in this line here, and this is the logo of the department. I am an associate faculty member at the Robert Bosch Center for Cyber Physical Systems, and this is the logo of that center, and I also are a member of the Center for Networked Intelligence. This is a Cisco CSR Corporate Social Responsibility Initiative under the EECS division, and this is the logo of Center for Networked Intelligence. I urge you to start with this logo, go to my parent institute, look up the activities of the Institute of Science under Science and Engineering and the systems related work that we do at our Department of Electronic Systems Engineering, and a lot of interdisciplinary research that happens at Robert Bosch Center for Cyber Physical Systems, and of course very focused networked intelligence work happening in the CNI including IoT. Okay, so that is a very important thing. Okay, so what are we going to cover in this course? It is a busy slide, okay, so you do not have to read every line. I will just tell you what exactly we plan to do in this course. First we will introduce the definition of IoT, what are the origins, we will take up a few applications and then we will understand IoT from those applications perspective. Quickly we will go into challenges of IoT. For example, there are going to be billions of devices that are going to get connected, right. So you need to have a unique ID equivalent of call it Aadhaar ID, right. So Aadhaar is something that we all know, and we have each one of us possess this Aadhaar ID, which has found to be extremely useful in tracking the vaccine dosages that we have had, first dose, second dose and so on, and it has been very useful, right. So having a unique ID is absolutely critical. So if you are looking at ID for IoT devices, you need to have a unique ID. So let us see, that is a challenge, how do you get to a unique ID. If you recall, the Aadhaar ID is not something that is that although is a number, right, it is a number that is generated for every human. It uses certain characteristics of ourselves, right. It uses biometric, it uses our physical signature that we sign, biometric data that is collected from each one of us, and all of that is fused together with some high performance algorithm perhaps, and then it generates a number, and that number is what we are often used to. So that number behind it is actually something that is unique about that human, right. So it is a fingerprint that is of that human is actually available. So can we do something like that to IoT devices? Can we have a fingerprint of a device, and if so, how do you generate such a fingerprint? Okay, so that is a very important challenge because you are talking about billions of devices, right. So this is important. Then I often recall several things that we read in our newspapers and ads that we come across in our daily life. You say fill and forget, right. So you fill up a tank and then you drive, forget about it, and you go hundreds and hundreds of kilometers. That used to be an ad for a motorcycle. Quite like that, you power once and then forget about it, right. So the device should keep sensing for at least a decade. It should you should not worry about that sensor, which means how do you ensure that it is power efficient, it is energy efficient? How do you ensure that the device is taking extremely low power, and you have planned your power management in a manner that it can survive for 10 years, at least 10 years, okay. So this is important because cost of replacement of battery is not simple. You need to employ someone and go and identify each one of these billions of devices in maybe if it is a human spread over a building, he has to go and identify each device, pull it out and put a new battery, and it is not going to work, and you are talking about hundreds and hundreds of sensors in a building and then scaling up to thousands in let us say a slightly large area and billions across the globe. So it is not going to work. That is one other thing. Then location, how do you know? You get data from let us say a sensor, how do you know from where it has come, what is the location identity of that sensor, okay. So that is a very important thing. So let us try and spend a little time on the location of a sensor. I mentioned to you powering is an important thing. So the second bullet here you can see is about addressing the power challenge. The origins for IoT started with RFID. So you must know RFID in quite some detail, okay. So that is important. Then energy harvesting, if you want to have a 10-year lifetime, what kind of energy harvesting modalities exist, and can you actually drive anything from harvested energies, or is it spooky by nature? Do you think that this is just some fad that people are going after, saying that you can drive embedded systems, or actually is it true that you can actually do something useful? Let us see some very compelling applications, particularly in the post COVID-19 world, where you could actually use the harvesting nature of energy and then bring in some simple applications, okay. So I will show you a few of them. Then that is just not all, right. It is not everything is, you can't do energy harvesting for all possible applications. You need batteries and you must have coin cell batteries put up to these embedded systems, maybe slightly larger power banks if there is, you are talking about a Raspberry Pi kind of a aggregation unit, you need power banks, and depending on the kind of device that you are talking of, you must definitely plan your power energy source. So even if you are using an energy source, you do not want to keep replacing that energy source, right. So battery based systems, power management is a very important thing. Now question is, often this is all you can do algorithmic, right. You can look at power management algorithms and say, okay, these are all the low power modes for these devices, how do I exploit them and all that. We will of course spend a lot of time understanding that, but then you have to find out ways, you have to pull levers which will allow you to exploit the hardware that is given to you, right. So this is an important, so you must know a little bit of hardware to pull the maximum juice out of any system in terms of its lifetime, okay. So you must know something about low dropout regulators and switching converters like DC-DC converters, particularly buck converters you should know, and all about the how to use them in your low power software. Then only sensing is not going to help, so you also need to do a little bit of actuation. So let us look at sensors like temperature sensor. Air quality is an important thing, because air quality index, quality of air that we breathe is an absolute critical thing, and we all know the importance of masks now, right. So why we wear masks? One is of course to ensure that we ward off the virus from entering our system, and the other is also to ensure that we breathe in good air. So a lot of things have to be filtered, the impurities in the air have to be filtered, so people wear masks even for that. So the quality of air is an important thing, okay. And then we look at some actuators, we will look at solenoid valves for instance, okay, and then look at how you understand solenoid valves in terms of its application to IoT, and what are the issues in solenoid valves, how can you repurpose them, and how this solenoid valve lifetime can be improved, how do you sense something about solenoid valve. Just an example of actuator that we will take and look at a complete analysis of that. And then IoT protocols, no course on IoT is complete without spending enough time on protocols like MQTT, which is publish subscribe, COAP, which is REST based, and of course WebSockets is an important thing. We have to also understand a little bit of WebSockets and associated applications. Now IoT is synonymous to low power wireless. So if you are talking about IoT, you must talk about connectivity, because we are talking about billions of connected devices, right. How do you ensure this connectivity? One is wired, that is a classic thing. It is not that wired is going to vanish and you are going to forget all about your serial ports and Ethernet and other related layer 2 MAC layer protocols. It is not that you are going to forget all that, but wireless is an important thing because untethered operation is important. You want to fix and forget, you want to power and forget. If you want to fix and forget and it should keep sensing some with a sensor connected to it, then you need a wireless connection to it. So right, you also have wireless connectivity in your homes. Often we say Wi-Fi router at home, right. So essentially it will have a back end connection which is connected to the internet, and what is end devices which users use things like laptops, mobile phones, printers also, right, printers, laptops, mobile phones, then normal PCs, all of them are connected to your internet device over Wi-Fi, and then from Wi-Fi the data is taken out onto the internet and some sort of a gateway service is offered there. So you need to understand low power wireless. So we will spend some time on Bluetooth low energy, we will spend some time on a little bit of industrial requirements for IoT, which is the TISH protocol. It is also called IEEE 802.15.4e, which is time synchronized channel hopping, and we will spend a little bit of time on Wi-Fi as well. This is not going to end, right. So you want to look at a large area where you take an agriculture field or so on, you have a lone sensor, and that lone sensor information is important. You do not want to have a network of them, you just have one lone sensor and you want that sensor data to be uploaded somewhere in the to the cloud. And how do you do that? So that requires you need to look at wide area low power wireless networks. You must look at a narrowband IoT, you must look at LTE which is a 4G technology which has come soon after the 3G networks. Now is the 4G era, and actually the 5G chipsets have also got released, but anyway we look at 4G. You look at CAT LTE M1, which is an important thing, and then of course you can't forget LoRa, which is a very important service for the low power wide area network. So overall we will look at all these things as much as possible. I would like to talk less and show you demonstrations of it, and so that you can actually build systems on your own. So this is going to be heavy technology oriented, demonstration oriented. This is very important. Okay, we are going to show you things so that you can build, and I will try and provide you as much as possible some free open source resources so that you can read up, you can understand and experiment them on your own. So that is about the overview of this course. Thank you very much.